Hello, fact families today. But first, here's our get ready questions. Pause the video and think about what is being represented here. And here are the answers. Oh, 2 and 3 are the same. I wonder why that is. So what is being represented here? I can see 7. And now my whole 7 has been split into 2 parts. There are 6 red counters and 1 yellow counter. Or I could say it, 7 is the whole, there is 1 yellow counter and 6 red counters. 7 is the whole, 6 is a part, and 1 is a part. And then in my second example, my 2 parts have just swapped places. It's a really nice part of addition. The parts can come in any order. Here's a second example. This time we're starting with the 2 parts. 6 plus 1 is equal to 7, and 1 plus 6 is equal to 7. Can you see the 2 parts have swapped places, but the whole has stayed in the same place? It's your turn to have a little go. What is being represented here? Have a look at the counters. Think about the 2 parts and think about the whole. Pause the video to have a go. How did you get on? We've got 8 red counters and 6 yellow counters. 8 is a part and 6 is a part. And 14 is our whole. So in our second example, we can have 6 is a part and 8 is a part, and 14 is still the whole. In the third and fourth examples, we're starting with 14, the whole, and then have the 2 parts, starting with the whole, and then having the 2 parts in a different order. Lovely. Your turn now. Have a go at question 1 on the worksheet. So when we come to subtraction, I can see 7 altogether, but 1 has gone. We've reduced by 1, which leaves us with 6. So 7 is my whole, that's what I'm starting with. And this time we've reduced by 6, we've subtracted 6, and we're left with 1. If I look at my counters, I can still see the 2 parts. The red counters are 1 part, and the yellow counter is another part, and 7 is the whole. So 7 is my whole, 1 is a part, and 6 is a part. And in the second example, it's exactly the same. Apart from, just like addition, the 2 parts have swapped places. I can start with one of the parts. So I can start with 6 and say that is equal to 7 minus 1. Or I could start with the other part. And this is where it's slightly different to addition. That our whole this time is in the middle of our 3 numbers. So we start with a part is equal to the whole, subtract a part. So when we swap our parts, it's the 2 outside numbers that swap, and the whole stays in the middle. This is a little bit more tricky than addition, so it's a good idea to read the number sentence through afterwards. Does that make sense? 6 is equal to 7 minus 1. Yes, that makes sense. 1 is equal to 7 minus 6. Yes, that makes sense. Here we have counters in a 10 frame and an addition fact family to help us. What I'd like you to do is pause the video and have a think about the subtraction fact family. Use the counters to help you, and the addition fact family, you can use that too. How did you get on with that? Here are the answers. And here we can see we've got a part plus a part is equal to the whole. Or we can have the whole is equal to a part plus a part. When we have a look at the subtraction fact family, we've got the whole minus a part is equal to a part. Or a part is equal to the whole minus a part. Brilliant, Tiny! You've gone and got yourself a 10 frame and some counters, and you've created a fact family. Pause the video here. Can we check Tiny's fact family? Okay, first of all, we know that part plus a part is equal to a whole, and a whole subtract a part is equal to a part. So in our example, we have 6 red counters and 3 yellow counters, which is equal to 9 counters. And that's exactly what Tiny has got. Brilliant work. In Tiny's second example, there is 3, which is a part, plus 9, which is the whole, is equal to 6, which is a part, which is incorrect, I'm afraid. But don't worry, Tiny. Remember from earlier, a great way to learn is through making mistakes. You can see you need a part plus a part to equal the whole. When we have a look at the subtraction, we can see you've got your whole, subtract a part, is equal to a part. Fantastic work. But in this final one, you've got a part, subtract a part, is equal to the whole. And we know for subtraction, we need the whole subtract a part to be equal to a part. Time for questions 2 and 3 on the worksheet. Good luck! My 10 frame now contains 7 red counters and 6 yellow counters. And here's part of my fact family to reflect this. Something that works really nicely alongside fact families is a part-whole model. The part-whole model works so well because we can cover up any of the numbers in the part-whole model and use the other 2 numbers to calculate the missing number. For example, I can cover up the whole and then add the 2 parts, 7 add 6, and it will give me 13, which is the whole. Or I could cover up one of the parts, 7, and then I can take the whole, subtract the part I do know, 6, which equals 7. The other place that this works really nicely is a bar model. Here I can take my whole, 13, and place it in a bar. And then I can take the 2 parts and place them in smaller bars underneath the whole. The proportions don't have to be exact here. All I'm showing is that my 2 parts, 7 and 6, when added together, will equal 13, my whole. Can you pause the video here and have a go at writing out the 8 calculations that will make up this fact family? Good luck. How did you get on with that? Did you have the same calculations as me? Great work if you did. You're all ready to have a go at the rest of the worksheet. Well done.